Today we're going to be working on Lesson 11, Factoring Expressions, which is on page 127 in your Eureka book. And you'll be starting with the classwork on example 1. So it says, use the model to answer the following questions. So we're going to kind of look at the model. As we notice, it's a tape diagram, which we've seen before. And we are going to be kind of answering the questions about the tape diagram. So the first thing it asks is how many 5s are in the model? 2. How many 3s are in the model? 2. What does this expression represent in words? So if we look at it, we see that we see the sum of 2 groups of 5 and the sum of 2 groups of 3. So the sum of 2 groups of 5 and 2 groups of 3. What expression could we write to represent the model? It might look something like this: 2 times 5 plus 2 times 3. So if we look at this, however we choose to find an answer, 5 plus 5 is 10, 3 plus 3 is 6, 10 plus 6 is 16, or we could say 2 times 5 is 10, 2 times 3 is 6, add those together, those are 16. So just kind of showing both ways. Looking at letter B, says use the new model and the previous model to answer the next set of questions. So again, we're going to look at this next model and see how many 5s are in the model, and there are 2. How many 3s are in the model, and there are 2. What does this show in words? What does the expression represent? 2 groups of the sum of 5 and 3 is what we would say. So 2 groups of the sum of 5 and 3. So we notice that we would still get the same answer if we look. 5 plus 3 is 8. 5 plus 3 is 8. 8 plus 8 is 16. So we haven't changed what we have. We haven't changed the value of what we have. We've changed the way we've arranged it. What expression could we write to represent this model? So there's a couple ways we could write it. It could be 5 plus 3 plus 5 plus 3. And notice we would need those parentheses because we want to do our 5 plus 3s that are in the parentheses first. And order of operations would tell us to do that. Or 2 times 5 plus 3. So either of those would work for that, to show that. So now we're going to move on to example 2. So I'll turn my page. Actually, at the top of this next page are a few questions about what we just looked at, so we'll do those first. In the model in part A, is the model in part A equivalent to the model in part B? And we would say yes. What relationship do we see happening on either side of the equal sign? So we would say on one side of the equal sign, we see 2 is being multiplied by 5. So 2 is being multiplied by 5. And then by 3. And if we think about the other side of the equal sign, so on one side we have 2 being multiplied by 5 and then by 3. 2 times 5 is 10. 2 times 3 is 6. But then the other tape diagram showed us that 5 and 3 are added first and then multiplied by 2. So 5 and 3 are added, then multiplied by 2. So this next question references something you may or may not remember from last year. It says, in grade 5 and in module 2 of this year, you have used similar reasoning to solve the problems. What is the name of the property that is used to say that 2 times the sum of 5 plus 3 is the same as 2 times 5 plus 2 times 3? And that would be called the distributive property. And the distributive property is what we're going to be learning about today and tomorrow as we factor expressions. So now we'll take a look at an example with variables. So just showing that these things don't change just because we have a letter involved, because sometimes that can be confusing. So it says, what does the model represent in words? So we're looking at these A's and B's, and we see 2A and we see 2B. So it's A plus plus B plus B. So that's one way we could say it, right? We could say 2A's plus 2B's might be another way we could say it. Or 2 times A plus 2 times B. So 2 times A plus 2 times B. So those are kind of what the model represents in words. And then it asks us, what does 2A mean? So now we're looking at those variables. So 2A just means that there are 2 A's. Or 2 times A. How many A's are in the model? 2. How many B's are in the model? 2. So I don't know if your book turns, but my page turns now to answer the rest of the questions. So I'm going to go turn my page and go to the next question. And it says, what expression could we write to represent this model, to represent the model? So notice that now our model has changed a little bit. We have A and B together, A and B together. So we have A plus B plus A plus B. So again, we're going to say, when it says how many A's are in the expression, we're going to write 2, and how many B's are in the expression 2. So what expression could we write to represent the model? So if we look at this one, what we might write is A plus B plus A plus B, or equals 2 times A plus B. Are these two expressions equivalent? So we would say yes. So now we're going to look at example 3, and this is where we've done something similar on daily review, where we use the greatest common factor and the distributive property to write equivalent expressions. So it says 3F plus 3G. So what is the question asking us to do? Well, we need to rewrite the expression as an equivalent expression in factored form, which means the expression is written as the product of factors. So what it's asking us to do is find the greatest common factor and rewrite an equivalent expression. So something that would give us the same answer, just written a different way. So it says, how would problem 1 look if we expanded each term? So it would look like this. We did this in lesson 9 and 10, 3 times F plus 3 times G. So all we're doing is expanding it. What is the greatest common factor in problem 1? Well, obviously there's not going to be one for F and G. So the only thing that you see that's in common is the 3. So the 3 is the greatest common factor. So it says, how can we use the greatest common factor to rewrite this expression? Well, 3 goes outside the parentheses. Three goes outside the parentheses. And F plus G goes inside. And you can just point up to the word parentheses if you don't want to have to write it again. So 3 goes outside the parentheses and F and G goes inside the parentheses. So what we're going to do is look back up here and write that. So we put 3 outside the parentheses and then F plus G inside the parentheses to show that those would be equivalent, because this means 3 times F plus 3 times G. So I'm going to turn my page to look at the next problem, which is problem 2. This was problem number 1 under example 3. So you should be looking at 6x plus 9y. So again, what is the question asking us to do? Find the GCF, right? That's the first thing we're going to do. And an equivalent expression. So then also equivalent expression. Those are the 2 things we need to do. Find the GCF, write an equivalent expression. So it says, how would problem 2 look if we expanded each term? So again, we want to kind of write it out to expand the term. That's the first thing we're going to do. Sorry guys, my camera's not working so well today. So it would look like this: 6 times x plus 9 times y. What is the greatest common factor in problem 2? Well, we have to think, what is going to be the largest number that can go into 6 and 9? The largest number that's going to divide into 6 and 9 is definitely going to be 3. And so then how can we use that? Well, we know our 3 is going to go outside the parentheses, and then the other side of our factor pair would go inside. So here's what that means. If we were to find greatest common factor this way, 1 times 6 and 2 times 3, 1 times 9 and 3 times 3, this will be our factor pair for 6, and this will be our factor pair for 9. So that helps us know what's going to go inside the parentheses. So if I go back up here, I know the greatest common factor goes outside. I make my parentheses. I know I'm going to have an x and a y. I know I'm going to have an addition sign between. So if 3 times 2 is 6, that means 2x has to go in here. 3 times 3 is 9, that means 3y has to go in here, because I should be able to look at what's in the parentheses, multiply it by 3, and get the same answer that's over here. 3 times 2x is 6x, 3 times 3y is 9y. Let's look at number 3 and see if we can find the same, apply the same thing. So it says 3c plus 11c. Is there a greatest common factor in problem 3? Well, I can look at 3 and 11 quickly and know that there's not going to be anything that divides into both, but I do notice that there is a letter C here and a letter C here. So actually, my greatest common factor is the letter C. So I can put the letter C outside the parentheses and then know that I can write 3 plus 11 inside the parentheses, because the C is what I'm factoring out. It's the only thing that both of those terms have in common. So let's look at number 4, 24b plus 8. So if I look at 24b plus 8, I notice I only have a variable in the first term. I don't have a variable with my 8, okay? So I know that I'm still going to be looking at what would be my greatest common factor of 24 and 8. So let's find that first. 1 times 8, 2 times 4, and there isn't going to be any other factor pairs that I can multiply to make 8. 1 times 24, I know I can do 2 times 12, 3 times 8, and 4 times 6. So if I look, my greatest common factor is 8. So I know 8 is going to go outside my parentheses. I'm going to put my parentheses here. I'm going to put an addition sign because I know I'm going to be adding. So 8 times 3 is 24, and I have a b. So it's going to be 3b. But when I look here, I see 8 times 1. So I'm still going to put that 1 here to show that 8 times 3b is 24b plus 8 times 1 is 8. So when it says why is there 1 in the parentheses, because I need to have the other side of that factor pair there. We are not going to answer these because we answered them while working through them. And you can turn the page or look at the very next one, which should be your exercises. So we're going to go through these together, just applying the distributive property and writing the equivalent expressions. So if I look at 7x plus 7y, I can see pretty quickly that obviously 7 is what they have in common. So 7 is going to go outside my parentheses, and x plus y is going to go inside because my greatest common factor is 7. 15g plus 20h. So again, I want to look at 15 and 20. I think what's the largest number that multiplies in? So I can find that by finding greatest common factor. But again, with 15 and 20, I know that's going to be 5. So 5 is going to go outside my parentheses. I'm going to put an addition sign between. I know I'm going to have a g and a h. I also know that 5 times 3 is 15. So it's going to be 3g plus 5 times 4 is 20. So 3g plus 4h, because if I take 5 times 3g, I get 15g. 5 times 4h, I get 20h. 18 and 42 might be one I don't know as well as far as what would be greatest common factor. So find that, and then you can pause the video, find greatest common factor, try letter C, and then check your work. Okay, so hopefully you tried to find the greatest common factor of that one on your own, and you would find that it's 6 once you do your factor pairs. So 6 is going to go outside your parentheses. Then you're going to look at what you multiply 6 by to get each one. So I'm going to put my addition sign in there. So 6 times 3 is 18, so it'd be 3m, because I don't want to forget that variable. 6 times 7 is 42 plus 7n. So 6 times the sum of 3m plus 7n. So try D, E, F, G, H on your own, and then pause the video, try those on your own, and then continue it to check your work. Okay, so hopefully you tried those on your own, or at least a few of them, so let's go over them. So D would be 3 times the sum of 10a plus 13b, because 3 is the largest number, the greatest common factor that divides into